Okay guys, let's look at these because I want to give you some time to work in class. And then I think we'll just go on to the next ones together. Okay, so the review this time I think is going to focus on a few different things. We're going to do some more linear inequalities, a couple more graphs from last week, and then we'll do some of that exponent stuff that we practiced like so much, I can't believe it. So this guy, I think, since it's a linear inequality, we're going to combine the x's first, right? So what is that, dx?
4x.
4x. And then to get x by itself, you're gonna divide. Okay, cool. So you get 12. Is that right? So x is less than or equal to 12. We'll graph that in a second. Let's solve the other one first, okay? So this guy, what should I do first? Thank you. So we're gonna have negative 3x. Minus times minus is plus how much? 18. Okay. Then on this one, you'd add 3x to the other side. Uh-oh, what would happen?
18 is less than 0.
It'd cancel out and you'd get 18 is less than 0. Is that true? There'd be no solution, right? So let's make this problem a little better. Instead of negative 3x, what do you guys want to make it? Negative 6? Should be easy. Let's do that. So now we're going to add 3x. And you get what? 18 less than negative 3x. And divide, but what happens if you divide by negative? This is really key. It's going to show up on your final more than once. Flip, right? What if this was positive? Would you flip then? No. Did we flip up here? No. Cool. Okay, so flip that sign, and that's going to be negative how much? 6. Okay, now let's graph both those real quick. So I'm just going to do a quick sketch, and graph it. So this guy's less than 12, so I'm going to go 0 and 10 just to kind of show it. Filled in or open? Is it equal to 12 or not? See the equals? And this is less than? So this way, right? And if you're going to write that in interval notation, it would go like this, right? I don't think that many problems on your review are going to need you to do that. But remember, this is going to be on the final. Like this parenthesis bracket stuff is definitely on that. We'll practice that more tomorrow, I was figuring. Okay? So I think we probably need to review that a little more. So anyway, this guy, x is less than pointy side, right? Negative 6. So we're going to say that's 0, negative 5, no equals, so open. Pointy side is less than. So I think again it's negative infinity to negative 6, except since there's no equals and it's open, they're both parentheses. Okay? Alright, this guy we did a bunch of, so I'm not going to go through it as in depth. We've been doing it and doing it and doing it, so I'm going to divide by negative 2. Why am I doing that?
You get y by itself.
You get y by itself. Why does that matter, Sean?
So then it'd be my x.
Slope intercept, right? mx plus b. So we want y by itself. What is this?
Or the negative 2x.
Minus 3. That's y equals m, the slope, and the intercept, right? So then we can just do a quick sketch. We start with the negative 2 or the negative 3? Negative 3. We go down, plot the point. This says negative 2 over 1, so I'm going to go down 2 over 1. That slope is indeed decreasing, right? It's going down, it's decreasing, so we know we did it right because it's negative. I mean, maybe we're off a little bit on our points, but it's kind of right at least. Okay? This guy, same thing. I'm going to move this. Let's see, get out of the way of the camera. So we have negative 2x and positive 15. I hit the pothole in my board. It's always a pain. One of these days I'll have to fix that. Positive, right? Negative. 15 over 3 is 5. Now if you're like, oh my gosh, this is a fraction, I'm clocking out. This is not like a fraction problem, right? It's even better when this thing is a fraction, because you can like see it better, I think. I mean, that's just me. But I used to be a little bit scared of fractions when I was younger too. I didn't have a teacher like Mr. Parks or anyone who knew anything. So, I mean, I was scared of fractions. But this shouldn't be scary. I mean, this just says start where? Yeah, start about right there, and then go where? This isn't equals, that's positive, okay? See, that's positive. Up 2 over 3. See, the fraction does, it's not like a hard fractional problem. And the slope is positive, it's increasing, so I know I'm good. Okay? Alright, I'm going to cut this video and do another little. Okay, so if they say like multiply or simplify, something like this is what you're going to run into. We did this a lot, so I'm assuming you guys should be pretty decent at it. Let's see. So x squared, x, these are all x bases, right? What's negative exponent mean? That's really key. We use that a lot in Algebra 2. What's it mean? Does it mean negative or positive? Remember, negative exponent is code for movement, right? So this says don't put that on the top, put it on the bottom. So if there's not a bottom, like there's not on this problem, make the bottom and move it down there. And then what's anything to the 0? You guys are good at that. That's 1, right? Okay, so I don't even really need to write that 1 down anymore, right? And then if you have x's like that, that's just really thinking like this, right? So what is left after I chop stuff off? 2 x's, but where are they? X squared. It's on the bottom. So that's the answer. It's got to stay on the bottom. Okay? If you wrote that answer as x to the negative 2, would that be okay? Yeah. Why no, Sean? Like if you write x to the negative 2, doesn't that really mean just move the x squared on the bottom? This and this are the exact same thing, so either answer is just as good. Okay? Depends what they have. Your test's all multiple choice, so I mean, you'll know which one it is. Okay, this guy, number 6, we did that again and again. I'm going to do distributing, right? So x times 2x is 2x squared, x times 5 is 5x, and I will switch to these two. So that's a negative 6x and a negative 15. Can we put any of those together?
5x and 6.
Those, right? So how many x's is that?
Minus x.
Minus 1. There we go. Okay, there's that. This guy looks just like that problem. So I look at it and I say, does anything cancel or get moved?
Every negative 3 moved up.
Okay, Nick said move this guy up. And make it positive, right? So how many m's really are there?
5.
And they're on top. So m to the 5th power. And then the a's, a bunch of them cancel just like this. I'm not going to write it out this time. How many are going to be left? 3, and where are they going to be?
On the top.
On the top. There you go. Done. Okay? So if you need to write it out like this, go ahead and do it if you need to. If you don't want to memorize a rule or something, that's fine. Okay? Just need to do something that works for you. Okay, last one, and then I'll let you guys work on stuff for a while. If it says this thing squared, what should we do with that thing? Should we write this? This is what some of my Algebra 2 students this year who shouldn't have passed Algebra 1 do a lot. If a college professor sees you do this, he's just like, you know nothing. I'm writing you off. Why do I even spend time? Yes? So what would you not want to write here? Which is so tempting. It's so tempting. I probably would have done it in Algebra 1. X squared and 5 squared is 25. If you just put that. It's not just wrong, it's really wrong. That's like one of those things I always watch out for, you know? I'm like, I've really got to get over that. Why is that wrong?
Because it is 5.
You can't just distribute this because those aren't multiplied. There's a plus. As soon as you see that plus, you got to go, you know what? I know there's just something else. You might not remember exactly what it is right off the top of your head, but you're like, oh man, there's something else there. It's missing, you know? Like these things are part of the answer, but they're not the whole thing. How do we get that whole answer? We go, what's it mean to be squared? It means write it down twice, right? And then we just do it exactly like that. Now watch. Let's see what was missing. Do we get x squared? We sure do. Do we get 25? We sure do. But is there more stuff?
Yeah.
There's also these two, which is what, 5x? And Nick's ahead of us. And then there's also these two, which is another 5x. In other words, there's double the cross terms. Do we have a shortcut formula? And I said I don't care if you do it this way or with the shortcut. So I think the answer is x squared and 10x and 25. That 10x was missing if we did it the other way. And it doesn't seem like you're like, well, I mean, I kind of got the answer right. It's not like a partially right thing. That's something that's really dangerous in math, okay, in algebra especially. And it filters through all the other classes. So really careful on that one. So if you wanted to do this fast, you can say, hey, the first thing squared, the last thing squared. And then you go double, if you remember, this is what we did. You go double the first thing times the last thing. And what is that? That's the 10x. So if you want to do it with the shortcut, I'm cool with that. If you want to write it out, I'm cool with that. What am I not cool with, or what is no one cool with? If you just put the blue, yeah? So watch out for that one, okay? I don't know if I gave you enough practice. Maybe I'll stick some more of that on the worksheet tomorrow. I'll probably give you 2 more of those. Okay, so that's enough for now. We'll do some factoring at the end of the class. So I think the last topic that's in this, mainly, there might be a couple other little things, is factoring. So just a quick review of factoring. What are the 3 factoring techniques we learned this year? And next year we review factoring, and I might do like 1 more, but... Okay. What they have in common, that's all sometimes known as the greatest common factor, right? What they have in common, you call it whatever you want. Okay, what else?
Difference of squares.
Difference of squares, thank you. What, Bailey? Perfect trinomial, yes, that is kind of like its own factoring technique, but how about we just go for trinomial, where we look at the last number and see what its factors are and stuff, right? Okay, so what do you guys think on number 9? Which one of those 3? When you see 3 terms, your first guess should be to try doing a trinomial, right? So you look at this last number, you say, all right, 9 and 7. It's not too many factors of 63. I think 3 goes in a certain number of times. But you could experiment with your calculator. Do you need to list them all?
No.
You just need the right combo. Is one of those going to work?
If they're both negative.
9 and 7 give you 16 somehow, and you're saying, well, not negative 16, and that's what Bailey's saying over there. So just write it down. Don't worry about negatives to begin with. Remember, just go x, 9, 7 as soon as you think you've got the right combination. And now worry about negatives. If you make them both negative, then they add up to negative 16, don't they? And if you check, real quick, always check yourself. That times that is positive 63 too. So it works. That plus that's that times that's that. It worked. Always go through a little quick check. You won't miss these. Okay. This guy, trinomial again, isn't it? Okay, what do we got? Factors of 5? 5's prime. So 5 and 1. Does that add up to 4? I mean, you could go like this, right? You go like minus 1, positive 5. But that gives you what? Negative 5. It adds up to positive 4, but it's not quite right. Is there anything else that we're missing? I don't think so. So some of yours, I don't know, there might be one that says cannot be factored. Some things can't. Okay, how about this guy? 20.
4 and 5.
4 and 5, that sounds like the right combination to me too. Why did I know 4 and 5 was right? I'm looking for 1. You guys with us? Cool, so which one's negative? 5, and this one's positive, right? Because now we get a negative 1 when they add, and they multiply to negative 20, we're done, right? If it said solve, I don't know if it says solve on any of yours, but you guys would do what after this? You'd put the factors equal to 0 and then solve, and you'd be done, okay? So I don't know if they say that or not. Okay, 12. It's different, right? It's not a trinomial. I don't see 3 things. No 3 terms. Difference of squares, so what do they have in common? They definitely have 7 and y in common. What's left?
Y squared.
You took one of the y's out.
Oh, y.
When you you take 7y out of itself, what's left? 1. Always just do a quick check. That times that's that, yep. That times that's that. If you put 0 there, it obviously wouldn't work. You'd see it didn't work real fast. Okay? And the last one, I don't think this is factoring, this is just distributing, right? So this is just combining like terms, so I figured we'd do one more of those. So if it's got a minus, make sure you distribute. Make sure you change. We did this a whole bunch, depending on what group you were in. Okay? So that's really key. This is something that happens a lot next year, and I can't be like, okay, I'm going to take a whole bunch of time reviewing this next year. So it's not going to happen. So I think 1 and -5 is -4 of the x squareds. Okay, got those. Then right here we've got -5 of the x's and +12, and we're done. Okay, so I think that should get you guys through all that worksheet, but we'll work on it some more tomorrow. Okay.